Ừm. आंटी गए दादी? Okay, so good morning, class, and welcome to the session. Okay, so let's get started. So those who have joined online, guys, please tell me if I'm audible.
Yes, sir.
Yes, sir. Number of participants are little less today, but okay, fair enough. It's already 15-20 minutes above the scheduled time. Let's get started. So yesterday, the last topic which we were discussing was our activation function. And one of the activation function was your ReLU. Okay. And I'm just doing a small recap. So activation function ReLU was something like this. So this you can say plus this. This was at 45 degree and y is equal to x. And on this line, x was less than or equal to 0. And that is why y was always equal to 0. So this is your activation function ReLU. Remember, ReLU is activation function and it is a non-linear function. It is a non-linear function. ReLU से related कोई doubt, कोई questions, guys, please बताओ. ReLU clear? So basically, keep one thing in mind that you are continuously getting an out. You are continuously getting the input, but not all input is significant. So to distinguish between significant and insignificant input, I am using the activation. Okay, ठीक है, fair enough. अगर कोई doubt question है तो बोलना. As of now, let's move forward. So common terms used in neural network. So convergence, cost function, gradient descent, stochastic gradient descent, learning rate decay, overfitting, and cross validation. Okay. So you might be knowing a bit of what is gradient descent, what is learning rate decay, but सारी चीजें वापस discuss करते हैं. Convergence. Let's discuss the first point. Convergence. Convergence का meaning क्या होता है? English meaning. What is the English meaning of convergence? Why same meaning यहाँ पे डाल दो? Or let me say, if I say my model has converged. My model has converged. ये सेंटेंस तुम्हारे माइंड में क्या आइडिया देता है? अगर तुम ये सेंटेंस सुनो तो तुम्हारे माइंड में क्या आइडिया है? मॉडल हैज बीन
यूनिफॉर्म होता है सर.
यूनिफॉर्म होता है. ओके, ठीक है. Yes. So my model has converged. It means I got the best model. My model has converged. It means I got the best model. See, remember your neural networks are iterative models. They are iterative. It means they will run many times. They will run many times before you get the final model. Your model will run many times before you get the final model. So when your model is running many times, so there should be some stopping criteria. ऐसा तो नहीं कि हमेशा दौड़ते रहोगे, कभी तो रुकोगे। सो जब मंजिल मिल जाएगी तब तो एटलीस्ट रुकोगे। ओके, सो एट सम पॉइंट यू नीड टू stop. So what is the criteria that I should stop? Or when you stop, probably that is known as your convergence. My model has converged. It means I have got the final model or the best model. So what could be the convergence criteria? The convergence criteria can be many. Let's say you have reached the desired level of accuracy. For you, the cutoff was, let's say, 90% or 92% or 93%, and that level of accuracy has been achieved. So I can say my model has now probably converged. Or remember, in your k-means, if you say maximum iteration is equal to 10, then your model will run 10 times and then it will stop. Remember? So similarly, in neural network, if you say in neural network, when you will do the coding, you will realize if you say iterations, if you say iterations as 50, so it will run for 50 times, or you can say maximum 50 times, and then it will stop. So number of iteration, desired accuracy, all these things can be taken as your convergence criteria. Convergence criteria as in तुम कहाँ पे stop करोगे, ठीक है? You cannot let your model to run for infinite amount of time. ठीक है? हमेशा के लिए तो run नहीं हो सकता. Somewhere it needs to stop, and that is what is known as your convergence. So when we will build the model, we will do the coding, you will see that there can be how your model converges. Next point, cost function. What is the cost function? Is this word cost function a new term for you guys? यार लाइफ में पहले भी सुना है?
सुना है सर।
सुना है? कहाँ सुना है? रिज एंड लाजो में सुना है। यस, सो रिज एंड लाजो में सुना है। सो ओके, चलो रिज एंड लाजो की बात निकली तो उसके बारे में 2 सेंटेंस बात कर लेते हैं, फिर आगे बढ़ लेंगे, तो है ना? रिज एंड लाजो में हमने सुना है। सो ओके, टेल मी व्हाट वाज द कॉस्ट फंक्शन इन रिज एंड व्हाट वाज द कॉस्ट फंक्शन इन लाजो। देखिए किसको कितना आता है। रिज का बताइए। एमएससी प्लस लैम्डा प्लस लैम्डा समेशन बीटा स्क्वायर। लाजो में एमएससी प्लस summation mod beta. ठीक है, these were the cost function in your ridge and lazo. Normally in linear regression we said that cost function is MSC, ठीक है ना, mean square error. But what do you mean by cost function? Cost function का मतलब क्या है? What is the meaning of cost function? क्यों चाहिए हमें cost function? What is the inherent meaning or the functionality of what you achieve by using a cost function? Cost function का दूसरा नाम क्या है? Loss function. Yes, cost function का दूसरा नाम है loss function. And what does this loss means? This loss function is nothing but it is a representation. Can I say it is a representation of the amount of error? Amount of error in your model. बराबर, सब लोग एग्री करते हो? So MSC is your mean square error. Mean square error is nothing but collection of your error. So it represents the amount of error in your model. It represents your amount of error in your model. Now, we are saying that neural network is a iterative model. Iterative model as in it will run number of times. It will iterate. And also remember one thing that from last class, from yesterday, I have been saying that neural networks work in the similar fashion like your human brain या human beings कह लो. ब्रेन हटा दो तो ह्यूमन बीइंग में कुछ बचा भी नहीं, मेन तो ब्रेन ही है, ठीक है, अदरवाइज ह्यूमन और जानवर एक ही है, ठीक है. सो इट वर्क्स एज योर ह्यूमन ब्रेन. एंड हाउ डज ह्यूमन लर्न्स बाय रिपीटिंग द प्रोसेस नंबर ऑफ टाइम, ठीक है. रिमेंबर हाउ द चाइल्ड लर्न्स टू वॉक, He tries many times, he falls, and then slowly he learns. बच्चे को चलना सिखाना नहीं पड़ता, दौड़ना सिखाना पड़ सकता है, बट चलना वो खुद से सीख लेता है. ठीक है. Repeating the process, but if you are repeating the process should be repeated in the right direction, or you can say in the correct direction. Process को अगर repeat करो तो correct direction में तो repeat करोगे, right? Now, if you are repeating it in correct direction, you should be able to reduce the error after every iteration. जो गलती पहले करी थी वो गलती दोबारा ना करो तो धीरे धीरे मॉडल इंप्रूव होता जाएगा. रिमेंबर, जो गलती पहले करी अगर वो दोबारा नहीं करो, slowly but surely your model will improve. So my error should reduce. Now your error should reduce, but how do you measure? How to measure that errors are reducing? How to measure the error that errors are reducing? Error reduce हो रहा है, ये पता कैसे चलेगा? ये let's say this is a question mark. ठीक है. Your error should keep on reducing. So if you want to reduce the error, first of all, you should measure the error. You should measure the error, and then only you can compare the error after every iteration. In first iteration, if my error was 10 unit, then in next iteration, my error should be less than 10 unit. Then only I can say that my model is progressing in the right direction. So to measure that your model is moving in the right direction, I should measure the error. And then if I keep on reducing the error, a stage will come where I can say that my model has converged. धीरे धीरे एरर कम करते जाओ तो मैं आखिरी में एक बेस्ट मॉडल आ जाएगा. That's the inherent concept of your cost function. So cost function is used to measure your loss. Loss is nothing but your error. And normally we are saying MSC is my cost function, and then there can be many variants of MSC. Okay. So basically, after every iteration, you will measure your loss, and your losses should keep on reducing. Your losses should keep on reducing, and then at the end we can say that I have got the best model, or you can say my model has converged. सेम चीज अपनी लाइफ में करके देख लो. तुम लोग जब इंटरव्यू दोगे तो पहला इंटरव्यू में 99% लोग फेल हो जाएंगे, बट वहां से कुछ एक्सपीरियंस आएगा, फिर उस पर इम्प्रूव करना, फिर एक और इंटरव्यू देना, वहां पर भी फेल हो गए, फिर एक और, फिर 5-6 इटरेशन बाद एक सक्सेस आती हुई दिखाई देगी. ठीक है ना. ठीक, जैसे पहले मॉक में सबके बहुत कम नंबर आए, बट आई एम होपिंग कि सेकंड मॉक में तुम लोग अपने लॉस को कम कर लोगे. ठीक है. नाउ gradient descent. Let's talk about the third term, gradient descent, GD. टेक्निकल टर्म्स में लोग इंडस्ट्री में ग्रेडियंट डिसेंट जितना बड़ा वर्ड नहीं बोलेंगे, लोग उसको जीडी बोलते रहेंगे. तो इस जीडी से कंफ्यूज मत होना. इट इज नॉट ग्रुप डिस्कशन, इट इज ग्रेडियंट डिसेंट. ठीक है. जीडी कितना है लोग करते रहेंगे. जीडी कम हुआ नहीं हुआ ऐसा बोलेंगे. ठीक है. तो डोंट गेट कंफ्यूज. वो जो तुम्हारा टेक लीड होगा या जो भी लीड डेटा साइंटिस्ट होगा वो ग्रेडियंट डिसेंट की बात कर रहा होगा. ऐसे बहुत से टेक्निकल वर्ड आएंगे. DQE आ जाएगा, डेटा क्वालिटी इशू. इंडस्ट्री में जार्गन है. कोई DQE है क्या, तो मतलब डेटा क्वालिटी इशू तो नहीं है. लेट्स टॉक अबाउट द ग्रेडियंट डिसेंट. इज दिस वर्ड अ न्यू टर्म और पहले भी सुना है? कहाँ सुना है?
सुना है सर, लॉजिस्टिक रिग्रेशन में सर.
लॉजिस्टिक में सुना है?
नहीं सर, सिग्मॉइड फंक्शन के तरह.
हाँ वैष्णवी कंप्लीट योर स्टेटमेंट. हाँ वो वर्ड यूज करो. यस. सो बेस्ड, हाँ Yes, that's the proper word to be used. It's a optimization algorithm. ये word याद रखो. It is a optimization algorithm. Yes, please. तुमने चश्मा नहीं लगाया तो अलग लग रहे हो. ठीक है, optimization algorithm. ठीक है. See, basically what I'm saying is, we are saying that cost function is used to capture the amount of error. It is used to capture the amount of error in your model. Error in your model at any given time. At any given time. Okay. Any given time means, let's say you are saying I should run my model. You are saying number of iterations as 50. So what is the error at first iteration, second iteration, third iteration? You can capture using your cost function, right? But so, and I'm saying that my cost, which is nothing but error, it should reduce. So how would you reduce the error? How would you come to know that in which direction or what hyperparameters should I change so that my errors will keep on reducing? So to help in that scenario, what I'm doing is I'm using the optimization algorithm. See guys, please remember one thing. Log ek mistake kar dete hain. They will say that gradient descent is a cost function. No, gradient descent is not a cost function. It runs along with your cost function, but it is an optimization algorithm. This optimization algorithm means it will help you to reach the point or reach this scenario where cost is least. Cost is least means error is least. So somewhere I may say cost, somewhere I may say error, or somewhere I may say loss. ये तीनों word in a way same है. I am using them interchangeably. Okay, so don't get confused. Whether I say cost, error, loss, they all in a way are meaning the same thing. I want to reach a point where my error or the cost or the loss is least. I can measure the cost or error or the loss using my cost function. And let me say this is your MSC. But then how to reach that point? I will use my gradient descent. I'll use my gradient descent. Gradient descent मैंने पहले एक बार समझाया, but let's assume you don't know anything about gradient descent. Let me say your cost function is MSC, mean square error. MSC is a square function. MSC is a square function, and trust me guys, a square function would always be something like this. The square function ऐसा ही होने वाला है. Why? Because for when x is -1, when x is -1 or x is +1, y value for both of them would be same. Whether x is +10 or -10, y की value अभी भी same होगी. ठीक है ना? So your cost function would be something like this. ठीक है? इसको हटा देते हैं और एक बड़ा सा MSC डाल देते हैं. Okay. Point A and point B. Point B represents where error is least or सबसे कम. So it is a point where I can say model has converged. अगर मैं पॉइंट बी पे पहुंच जाऊं तो मैं कह सकता हूं मेरा मॉडल अब फाइनल मॉडल तैयार हो चुका है. ठीक है. Now let me say A is the starting point. A is the starting point. And imagine you have given the number of iterations as 50. This 50 is just a number. It can be 500, it can be 600, it can be 10, it can be whatever. Iteration is 50. So all this part, ऐसे ही explain करता हूं मैं, all this part, whichever I have marked in red, is not visible to you after first iteration. After first iteration, this part is not visible to you because this part would be created after multiple iteration. Okay, so standing at point A, you cannot see point B. Point B तुम्हें दिखता नहीं है, and you don't know how far point B is. Point B कहाँ है नहीं पता, कितनी दूर है नहीं पता, but you know somewhere point B is there. Point B is your destination. इसीलिए लाइफ में कहते हैं ना, एम बहुत जरूरी है. अगर एम होगा तो धीरे से पहुंच जाओगे मेहनत करते करते. You know your aim, you know your destination, but you don't know where it is and how far it is. Right? Standing at point A, you cannot see point B. But you know your aim. Your aim is to reach the point B. What is this black curve? This black curve is nothing but your loss function. That is, in this case, let's say MSC. ये loss function है. On this loss function, what I will use my GD. मैं इसके GD के साथ combine कर दूंगा. GD is your gradient descent. What is gradient? Gradient is nothing but slope. Descent means to decrease. Descent का मतलब क्या होता है? नीचे उतरना, to decrease, right? Now, standing at point A, you don't know where the point B is, how far the point B is. You don't know in which direction to get there. Okay, so what do you do at point A? What do? You take your dy by dx. At point A, you do your dy by dx. Okay, so dy by dx is nothing but your slope. At standing at point A, you are not able to decide whether you should move in this direction or in this direction. In direction 1, or should I move in direction 2? तुम्हें नहीं पता. So what do? You take your dy by dx. Dy by dx is nothing but your slope. Now this will give you the direction. This will give you the direction. In which direction should I travel so that my slope or my gradient will reduce? ठीक है? So तुम्हें पता चल जाएगा. So now what do? Now you get the direction that I should travel in direction 2. So you take a small step. You take a small step, that is your A1. At A1, you will find your MSC. You will compare the MSC. Compare this MSC at point number A. So if it is in right direction, MSC at A1 would be less than your MSC at A. It means you are traveling in the right direction. Then you again take a small step A2. You find the error at step A2. Compare it with your error at A1. The error normally will keep on reducing. Now again, you take a small step. And remember, every time I am stressing on the small step. छोटे छोटे कदम उठा रहा हूं. And why small step? Why not a very big step? Okay. So in a why small step? Why not a large step? सोचो. अच्छा चलो ठीक है. अगर नहीं समझ में आ रहा तो थोड़ा और सोचते रहो, शायद समझ में आ जाए. you keep on taking the small step, A2, A3, all these steps you keep on taking. Let's say you reach the step AN, and then you come to AN plus 1, and probably your AN plus 2, whatever. Now, when you come to this point, AN plus 1, AN plus 2, your errors will start to increase, which will give you the idea or information that your best point has been left behind. Your best point has been left behind. So what you will do, you will again come back, and probably you will reach your point B. Okay? You will reach your point B. This is what the concept of gradient descent. अब ये gradient descent का समझ में आ गया, तो बस sklearn से हमें function import करना है और gradient. कुछ लोग बोल रहे थे ना कि stochastic gradient descent using gradient descent. ठीक है? So once you learn the neural network, gradient descent मेरे कहे बिना भी तुम लोग कर सकते हो, कोई issue नहीं है. ठीक है? Take 2 minutes and try making your notes whatever you want. Done? Shall we move ahead?
Yes.
Yes. Okay, now let's come to this thing. अच्छा, stochastic gradient descent, learning rate decay. SGD को 2 मिनट बाद आते हैं, पहले लर्निंग रेट पे जरा फोकस कर लेते हैं. ओके, सो लर्निंग रेट, सी नाउ इन इंडस्ट्री में लोग ऐसा इतना बड़ा लर्निंग रेट वर्ड यूज नहीं करेंगे, वो लोग LR करते रहेंगे. ठीक है, तो LR समझ जाना, इट इज नथिंग बट योर लर्निंग रेट. ठीक है, LR कितना है, व्हाट इज LR? Learning rate. Let me say, if I ask this question, what is your learning rate in data science? तो क्या लगता है, क्या आंसर करोगे? हर एक इंडिविजुअल का लर्निंग रेट कुछ अलग होगा. बट व्हाट इज लर्निंग रेट मीन? फॉरगेट अबाउट डेटा साइंस. इन इंग्लिश और इन normal life, what does LR mean? Learning rate. Learning with respect to time. Okay, learning with respect to time. ठीक है, कितना गेन कर सकते हो. बट रेट का मतलब क्या होता है?
Sir, at which speed or at which pace?
At which speed or pace. So basically, at which speed or pace you learn. Or in short, if I say in simple terms, how fast or slow you learn anything. कितनी जल्दी या कितनी तेज सीखते हो तुम कोई चीज. That is nothing but your learning. So if your LR is fast, or if your LR is high, model will converge in less time. Will people agree to my this statement? अगर लर्निंग रेट तेज है तो मॉडल जल्दी बन जाएगा, और लर्निंग रेट अगर स्लो है तो मॉडल को ज्यादा टाइम लग सकता है. ठीक है. If LR is low, model will take more time. अच्छा, LR को ना हमेशा अपने एक रियल लाइफ एग्जांपल से कनेक्ट करके रखो, और वो एग्जांपल तुम सबकी लाइफ में बहुत बार हुआ है. और वो एग्जांपल है, सपोज कर हम सब ने इंजीनियरिंग करी है और हमें पता है हम सब ने इंजीनियरिंग कैसे करी है, किसने कैसा करा है सबको पता है, अपने अपने लाइफ के अंदर झांक के देख लो. सो लेट्स से एग्जाम इज देयर ऑन मंडे. ठीक है, सेमेस्टर का एग्जाम है, उसमें 6 सब्जेक्ट्स हैं, एंड वन ऑफ द सब्जेक्ट तुमने स्टार्ट करा. लेट्स से कैंडिडेट ए ने स्टार्ट किया. योर नेम प्रथमेश. सो लेट्स से प्रथमेश ने स्टार्ट किया ऑन सैटरडे, एंड कार्तिक ने स्टार्ट किया ऑन संडे. ऐसा बहुत बार हुआ होगा सबकी लाइफ में. वन नाइट मैच खेला और अगले दिन एग्जाम दे दिया. रात भर पढ़ा, उससे पहले कुछ नहीं पढ़ा था, या 24 घंटे लगातार पढ़ा फिर अगले दिन एग्जाम दे दिया. ऐसा सब बहुतों ने करा है. अगर खुद नहीं किया होगा तो ऐसे बहुत से लोगों को जानते होंगे, तुम्हारे हॉस्टल में होंगे जहाँ पे. तो प्रथमेश ने स्टार्ट किया, प्रथमेश स्टार्टेड प्रिपेयरिंग ऑन सैटरडे एंड कार्तिक स्टार्टेड प्रिपेयरिंग ऑन संडे. सो नाउ ऑब्वियसली कार्तिक का जो लर्निंग रेट होगा वुड बी, द लर्निंग रेट ऑफ कार्तिक वुड बी हायर देन ऑफ प्रथमेश. उसके पास टाइम कम है, माइंड ज्यादा एक्टिवली चल रहा होगा. important चीजें पढ़ेगा. So what Karthik will do, since he just has 24 hours or 12 hours, he will study very important topics, and Prathamesh will study, let's say, important topics, very important topics also, and some important topics also, and some not so important topics. ठीक है. अब क्या होगा, since Karthik learning rate is very high, he has left few topics. वो कुछ टॉपिक्स को उसने छोड़ दिया है. But probably Prathamesh has covered more topics. ठीक है. Now advantage of Karthik is that he can build a model in less amount of time. Advantage of Prathamesh is that though he is taking more time, but chances is that he might get a better model because his learning rate is low. धीरे धीरे सीख रहा है, but chances of missing anything are less. Karthik, he started on Sunday, तो उसके पास लर्निंग रेट तो हाई है, but there is chances that he might miss many things. He might miss many things. Keep this example of Karthik and Prathamesh, और अब वापस आ जाओ लर्निंग रेट पे. What would be the impact of your learning rate? Let me draw two diagrams. Diagram number 1. Diagram number 2. In which diagram do you think the LR is more? LR high किसमें? सब लोग प्लीज बताओ, A और B. Sorry, 1 or 2?
Sir, 2.
2 में ज्यादा है. 2 में ज्यादा है इसलिए because in less number of steps, 1, 2, 3, 4, 5, probably 6 7, 8. And over here, 1, 2, 3, 4. There are so many steps. Let's say it takes around 20 steps. 20th step, it comes over here. So LR is high in model 2. So it takes less time. Less time and less money also. Money भी कम आएगा, guys. एक चीज याद रखना. So let's say when you are running your model on your laptop, probably you may not realize that because अपने laptop पे when you are running, you are not paying anything. But the same thing when you are running on the cloud. At the end, तो तुम cloud पे run करोगे, या जहाँ पे भी. Over there, the model 2 may be, or model 1 may be around 5 to 10 times more expensive than your model 2. Because it will run for more times and it will use more CPU and more computation power. And on cloud, you have to pay for your computation power. Okay? Whether it is Amazon or whether it is Google or Azure. Okay? So in model 2, LR is high, so it takes less time and less money. It takes less time and less money. So which model should I prefer, 1 or 2? कौन सा बढ़िया है, 1 या 2? बस वही तुम्हें समझना है.
Sir, when situation depends.
अपना स्टेटमेंट रिपीट करो वापस. Yes. See, the advantage of model 2 is that it will take less time and money. But problem with model 2 is that it may miss the point B. Point B हो सकता है miss हो जाए. For example, let me say from point number 5, it directly, if your step size is very large, it may directly go to your point number 7. And then if it loses the direction, it may go to point number 8 or point number 9 or whatever. So errors will start to increase. It may miss your optimum point. When LR is low, time taken may be more, but the chances of missing the optimum point are very rare. तुम मंजिल से आगे निकल गए, मंजिल पीछे रह गई. ठीक है, रेस में दौड़े और रुके ही नहीं, भाग गए, तो तुमको मेडल कैसे पहनाया जाएगा बताओ? वैसा कुछ समझ लो. ठीक है. So in model 2, let me say from point number 5, if your step size is very large, you may not reach the point number 6, you may reach the point number 7. And if you lose the direction, you keep on traveling to point number 8, 9, whatever. Okay? So neither the LR, so LR, सब लोग please याद रखना, what is the problem associated with low LR? Problem associated with low LR is that it will take more time and money. But the advantage with low LR is that you do not miss the optimum point. Life में सबका कुछ फायदा कुछ नुकसान होता है वैसे ही. So low LR has its own advantage, but comes with its own disadvantage also. But if you have to choose between low LR and high LR, right answer is low LR. पैसा ज्यादा लगेगा, टाइम ज्यादा लगेगा, लेकिन at the end you will get the good model. Result तो अच्छा आएगा. ठीक है. If someone asks you what is the which LR would you choose, then tell him what are the advantage and disadvantage of low LR and high LR. Now, same thing. Let's write down the problem with high LR. Problem with high LR is that you may miss the optimum point. You may miss the optimum point. You do not get the best model. The best model means the model which has the लीस्ट एरर, वो पॉइंट तुम्हारा मिस हो सकता है, बट कॉस्ट एंड टाइम इज लेस. Cost and time is less. Now take 2 minutes, whatever notes you want to prepare, prepare it. Correct? सबको समझ में आया यहाँ तक?
Done, sir.
Done? अच्छा, now come to this point. LR decay. Learning rate decay. So before I move to learning rate decay, is everyone clear with the idea of LR? How fast or slow your model runs? So basically you may have your high LR, you may have your low LR. Both of them have some advantage and some disadvantage. Okay. So what I can do is, using my LR decay, I can overcome the disadvantages associated with both high LR and low LR. Using my LR decay, I can handle the disadvantages associated with your high LR and also with your low LR. अच्छा, वैसे डिके का मतलब क्या होता है? डिके का मतलब
खराब होना.
खराब होना. वैसे डिके का मतलब कहीं कहीं पे स्लो डाउन होना भी होता है. स्लो डाउन हो जाना. यहाँ पे थोड़ी देर के लिए समझ लो कि स्लो डाउन हो रहा है. इट इज मॉडल इज डिकेइंग आउट, इट इज स्लोइंग आउट. नाउ मैं दो छोटे से मॉडल एमएससी वापस क्रिएट कर देता हूँ. This is with your low LR. This is with your low LR and high LR. ठीक है. ओके. अब एक तीसरा मॉडल क्रिएट कर देता हूँ. LR with decay. Let me say model 1 और डायग्राम 1, 2 and 3. जरा देखो तो सही, क्या 3 में डिके हो रहा है? Is there a decay? हो रहा है?
Yes, sir.
अच्छा, from model 3, so basically what is the aim of my decay? Aim of my decay is to overcome the disadvantages associated with high LR and low LR. देखो क्या वो disadvantages overcome हो रही? What is the disadvantage with high LR? You may miss the optimum point. Yes, so you may miss the optimum point. Yes, Vaishnavi. And what is the disadvantage with low LR? It takes more time.
More time.
Yes, it takes more time. Yes. So in the diagram 3, obviously A is your starting point. You move to your A1, then your A2. See, when your model starts to train, when your model starts to train, at the starting, you would be having high errors. मॉडल जब बिल्ड होना स्टार्ट हुआ तो मॉडल में एरर्स ज्यादा होंगे. एरर्स विल स्लोली रिड्यूस. सो एट द स्टार्टिंग you have the privilege to take large steps. You have the privilege to take large steps. Example, ऐसा एक एग्जाम्पल लेके देखते हैं. Let me take an example. Let me say at the starting, accuracy was just 30%. Let me say. So maximum accuracy can be 100%. So you know that there is a big difference between 30 and 100%, 70% का difference है. So it means you can, at this point, you have the privilege to take the large steps. So you take a large step and your accuracy goes to, let's say, 50. Still, you know that I can take a large step. You take a large step, it comes out to be 70. But now, accuracy is 70 and you know that maximum accuracy can be 100%. Okay? So if you want, you can reduce your learning rate. Okay? So you reduce your learning rate instead of, let's say, 20%, तुमने उसको reduce कर दिया. Now you are taking as small steps and you slowly reach your 85%. So after a point, when you see that errors are reducing slowly, you will decay your learning rate so that you do not miss your optimum point. And guys, देखो life में भी ना तुम देखो ऐसा ही होने वाला है. When you start learning something, you will learn many things very fast. Suppose करो तुम एक नया language सीख रहे हो, or let me say you are learning your data science thing only. So at the starting, you will learn many things, but beyond a point, it would be very difficult to increase your knowledge. ठीक है? तुमने मैथ्स में जितना कुछ सीखना था सीख लिया. अब तुम मैथ्स में कितना कुछ सीख पाते हो? बहुत कम. So at the starting, when the child is very young, he is learning so many things every day. But जैसे जैसे एज बढ़ती जाएगी, his learning rate will decay out. स्कोप ही नहीं बचता है. Suppose you are learning to play football and you practice it for 1 year. तो हो सकता है you are able to play at the city level. But it doesn't mean that you practice for 2 years or 3 years, you would be able to play at the national level. एक साल की मेहनत तुम्हें सिटी लेवल तक तो ला सकती है, but beyond that point, your learning rate will decay out. तुम्हारी जितनी जो natural capability है, it will start coming into the play. It will start coming into the picture. तुम्हारा talent भी तो एक चीज है ना. Talent, with your effort, you can improve your performance, but beyond a point, learning rate will decay out. The same concept is being used over here. So at the starting, I am having high LR because I know that there is a large scope of improvement. But beyond one point, I will reduce my LR so that I do not miss the optimum point. That is the concept of your learning rate और LR with decay. ठीक है, इसको कुछ ऐसे नोट डाउन कर लो that LR decay is used to overcome the advantage or overcome the disadvantages associated with your high LR and also with your low LR, so that time taken is also reduced and you do not miss your optimum point as well. ठीक है guys? Shall we move ahead? So we have discussed convergence, cost function, gradient descent, learning rate decay. Okay, now let's see our stochastic gradient descent, SGD. Okay, so SGD ideas again related to your GD only, but let's see stochastic gradient descent. SGD. अच्छा, सब लोग प्लीज जरा गूगल करो और इसका इंग्लिश मीनिंग पता लगाओ, इस वर्ड का इंग्लिश मीनिंग क्या है।
So similar ratio.
Tell me, repeat your statement, please.
Sir, it's in the chemistry similar ratio. Stochastic.
Stochastic means similar.
Yes, sir. We are mixing the chemicals in the similar ratio. We are balancing the equation.
Okay.
So it says having a random probability distribution or pattern that may be analyzed statistically, but may not be predicted precisely.
Okay. So तुमने जो बोला, whatever you said, the main word which I wanted to hear was rand. ठीक है. So stochastic has something to do with random. एक काम करते हैं, हम भी गूगल करते हैं. ठीक है ना? So let's say आजकल मेरी जिंदगी इन फैक्ट्स में बीत रही है, बट फिलहाल हम कैसा कर सकते हैं? स्कॉस्टिक की स्पेलिंग क्या है? तुम लोग एक तो इतने बड़े बड़े स्पेलिंग्स लेके आते हो. Having a random probability distribution or pattern that may be analyzed statistically but may not be predicted precisely. ठीक है. So बहुत बड़ी सी definition है, but in a way it is a simple for data scientists. It is a random probability distribution. Random probability stochastic distribution. अच्छा, now see, basically in gradient descent, when I'm using a gradient descent, we start from one point. You choose any point. You randomly choose one point, and from that point, you take it as a starting point, and you start traveling in a direction. So you might have chosen a point A, or someone might have chosen a point C, or someone might have chosen a point B, whatever. Randomly, कोई सा भी point आ गया. So now the chances, or let me say, if someone has chosen अगर point D आ गया हो, if you are starting with point D, then reaching this optimum point. So let me say, if you are compare point A, B, D, or C, if you start from point D, then you will reach your optimum point very early. Correct? If you are choosing point A, it will take maximum amount of time. If you take point B, it will take more than A, but it will take less than A, but more than D. So basically, to overcome these type of problem in stochastic gradient descent, what happens is you can have multiple starting point. हमको नहीं पता कौन सा point से start करेंगे तो जल्दी पहुंच जाएंगे. So you have a multiple starting point. That is one thing. Another thing is, in real life, many a times your cost function may not be that good. It may be something like this. Square तो है, but it is not a exactly square but little bit twisted function. Let me say point this. Consider this is your cost function. It increases a bit and then again it goes down or whatever, right? Now, let me call some point x1, point x2, point x3. If you start from point A and you apply the concept of gradient descent, you will reach the point x1. You can reach the point x1. But after your point x1, when you reach, let's say, point a n plus 1 or point a n plus 2, your algorithm will tell you that errors have started to increase. And keeping in mind that you cannot see the point x2 and x3. अगर x2 and x3 हमें दिख सकता है तो हम directly वहां पहुंच जाते हैं. But since you cannot see point x2 and x3, you will get an impression that your errors have started to increase once you reach this point a n plus 1 or a n plus 2. So your algorithm will push you back to point x1 कि भाई नीचे जाओ, तुम्हारे errors बढ़ रहे हैं. But do you notice one thing, that the best point, best scenario is x2. Best तो x2 है, but तुम x2 तक पहुंच नहीं पा रहे हो. And the same thing can happen. Let's say if you start with point B, you keep on reducing your errors. And let me say when you reach this point Bn plus 1 or Bn plus 2, you will get to know, your algorithm will say that now your errors have started to increase. But neither your x1, neither your x3 is the best case scenario. Best case scenario कौन सा है? x2 है और तुम वहां तक पहुंच नहीं पा रहे हो. So have you heard about these type of terms in your life? Local minima and global minima. आज की डेट में याद नहीं होगा लेकिन कभी तो सुना होगा. Local minima and global minima. So basically your point x1 and x3 are local minima, but point x2 is your global minima. It is your global minima. ठीक है? And at global minima, the value would be least. Value would be least. Your aim is to reach the global minima and not to the local minima. But if you are using only the concept of gradient descent, depending upon which position you are starting, you may be able to reach local minima, you may be able to reach global minima, you may not be able to reach the global minima. ठीक है? Local and global minima. चाहना तो घर जाके एक बार थोड़ा सा और सर्च कर लेना कि local minima, global minima क्या होता है in mathematics. This mathematics terminology is being used in your this data science. Now, this was in your gradient descent. Let me draw the similar kind of curve. And again, your point x1, x2, and x3. So I want to reach the point x2, which is my global minima, Now what I am having A, I am having B, I am having C, I am having D, I am having E, I am having F. Your A, comma B, comma C, comma D, comma E, comma F, or it can be till your whatever n. All these are your random starting points. These are your random starting points. Randomly, हमने इतने सारे points choose कर लिया. Randomly, I am starting with these points. Now, if you are starting at point C or point D, then obviously you can reach your point x2, which is your global minimum. Okay? So this is where we use this is what the responsive gradient descent is. You don't need to know. Let's say these are just random starting points. कोई भी सिनेरियो ले लो तुम, ठीक है? सिनेरियो एज इन, लेट मी से, सपोज करो तुम्हारे पास 1000 रिकॉर्ड्स है, तुमने 50 रिकॉर्ड्स लिए, so these 50 records will represent some scenario. So instead of taking first 50 record, you take in between 50 record. तुम कहीं 20 से स्टार्ट करो, you take one group, create one packet, then you create another packet, and सब पे अलग अलग फंक्शन रन करो, ठीक है? And somewhere, so now you will have multiple starting points. These A, B, C, D are just the representation point. ठीक है? तुम कुछ कहीं से भी स्टार्ट कर लो. Your aim is to reach a point where your error is least. ठीक है? So basically, if you are not having just one starting point, multiple starting point. Suppose for 1000 records पे तुम अपना मॉडल ट्रेन कर रहे थे. You don't take the first 50 records. You take 50 records, but in between 50 records, and you start creating your model. Then you choose next 50 record, any 50 record, and you again start building your model. That is how your model will get converted. जब कोडिंग करेंगे तो तुम देखोगे. तो हमें तो रैंडमली लेना चाहिए ना. हम लोग रैंडम सैम्पलिंग क्यों करते हैं? So जब भी तुम मॉडल बिल्ड करोगे, मॉडल योर डेटा यू शुड बी पासिंग इज रैंडमली ओनली. अदरवाइज हो सकता है ऊपर के 50 रिकॉर्ड्स तो बहुत अच्छे हों, जहां पे यू कैन इजिली डू द प्रेडिक्शन, और बाद के रिकॉर्ड्स में हाई रैंडमनेस हो, राइट? सो मॉडल तो हमेशा रैंडमली बिल्ड करना ही है. अब इस पे आ जाओ. लर्निंग रेट डीके हो गया, स्कॉस्टिक लर्निंग रेट डीके, स्कॉस्टिक ग्रेडियंट डिसेंट, कॉस्ट फंक्शन, कन्वर्जेंस. सी, तुम थोड़ा सा कंफ्यूज कर रहे हो. इफ यू आर यूजिंग स्कॉस्टिक ग्रेडियंट डिसेंट, आई एग्री कि हो सकता है कॉस्ट ज्यादा आ जाए, बट तुम्हारा मॉडल तो अच्छा है ना. सो इन स्कॉस्टिक ग्रेडियंट डिसेंट द चांसेस ऑफ रीचिंग द ग्लोबल मिनिमम वुड बी वेरी हाई ना. सपोज करो तुमने, लेट्स से इफ दिस इज योर कॉस्ट फंक्शन, अगर if this is your cost function and if you start with point A, fair enough, you stop at point X1, so you will say my cost is less, but then you don't have the best model also, so तुम्हें एक trade off करना पड़ेगा. Now come to this overfitting, dropout and cross validation. ठीक है? अच्छा, now again the same question. Is this word overfitting new for you? या लाइफ में पहले कहीं सुना है? सुना है? क्या सुना है?
Yes, sir.
कोई एक दिन बताओ, तुम बताओ. तुम बताओ. अच्छा पीछे तुम बहुत सुबह से कुछ बोलना चाह रहे हो.
Sir,
Yeah, हाँ ठीक है. वैष्णव, you tell me. तुम बताओ, थोड़ा धीरे बताओ. हाँ, फिर सब पूरा रिपीट करो. वो रिजल्ट ऑन टेस्ट डेटा. Yes, so that's the right answer probably. So overfitting, what I'm saying is you are building a very complicated model. ठीक है? Complicated model. तुमने जो बोला वो ठीक बोला, उसमें एक वर्ड और याद कर लो. इन overfitting, mimic, हाँ वर्ड mimic याद कर लो. It tries to model, tries to mimic the data. Model tries to mimic the data. क्वेश्चन समझ में नहीं आया, बस रट लिया, वैसा ओवरफिटिंग. ठीक है ना? मॉडल ट्राइज टू मिमिक द data. So in overfitting, your model gives very good result on your trained data and poor results on your test data. अच्छा, remember before doing Ridge and Lazo, मैंने एक scenario create किया था. याद आ रहा है सबको? Do you remember MAPE, mean absolute percentage error, was in some millions on your test data? याद आता है? एक ऐसा डेटा सेट दिया था जिसमें अराउंड 300 कॉलम्स थे. On trained data, MAPE was only 5 to 6%, but on test data it was in millions. याद आता है? So over there the model was overfitted और उसके बाद हमने Ridge and Lazo यूज करके overfitting को overcome किया था. अरे करा था कि नहीं करा था? पता किया था ना? तो overfitting सबको समझ में आ रही है? If model has overfitted, what would be the problem associated? Now come to this slide. So overfitting. So you understand what overfitting is. Now there are two ways to overcome the overfitting. Two ways to overcome overfitting. And what are the two ways? One is your dropout. ये dropout स्कूल वाला dropout नहीं है, ठीक है? और तुम लोग dropout भी मत करना. And another is your cross validation. ठीक है? ठीक है, भले ड्रॉप आउट बाय चॉइस हो, ठीक है, बट फिर भी ड्रॉप आउट मत करो. ठीक है, ड्रॉप आउट एंड क्रॉस वैलिडेशन. ड्रॉप आउट तुम लोग अभी समझ नहीं पाओगे, तो इसको हम अभी डिस्कस नहीं करेंगे. We will not discuss right now, but we will discuss what dropout is once I explain you neural networks. वैसे अभी तक न्यूरल नेटवर्क स्टार्ट नहीं हुआ है, अभी जस्ट उसका बैकग्राउंड बिल्ड कर न्यूरल नेटवर्क स्टार्ट करेंगे. ठीक है, अनदर इज योर क्रॉस वैलिडेशन व्हिच इज आल्सो नोन एज योर CV. So what is cross validation in neural network? One first line answer would be it is one of the methodology to overcome the overfitting. It is, please go note down kar lo. Cross validation is a methodology or the technique to overcome the overfitting. Okay. And now we will see what basically cross validation is. Cross validation hota hai. So what is the aim of cross validation? To overcome the overfitting problem. Okay. Let's take an example. Okay. Suppose you have 10,000 records. Total records are 10,000. Then what do? You do your 80-20 ka sampling, random sampling. So when you do 80-20 sampling, let me say 8,000 records will come over here, or I'll say any 8,000 and any 2,000 will go in your test data. Ye aa jayega train data. So let's forget about the test data. Test data does not play any role while your model training. Model to train data hi pe build hota hai. Your model is built on your train data. So on this 80,000, when you are building the model, you divide this 80,000, let me say again in two parts. 7,000 and 1,000. Okay. Now on this 7,000, you will build the model. And on these 1,000, you will validate the model. You will validate the model. Remember, your neural networks are iterative process. Iterative process as in it will run multiple times. And after every iteration, after every iteration, you can measure the loss on both the validation, both on the train data, that is your 7,000 in this case, and on your validation data, that is your 1,000. I repeat, these 1,000 records are not being used for model building. Your model is being built only on 7,000. और उस 7,000 को हमने नाम दे दिया है ट्रेन, एंड ये 1,000 हो गया है वैलिडेशन. एनी डाउट, एनी क्वेश्चन यहां तक? स्पेशली दोज हु आर इन ऑनलाइन. आई डोंट वांट कि कोई बोले कि सर शुरू से एक्सप्लेन करो. यहां तक सबको समझ में आया?
यस सर.
ओके. बाकी और लोग, ध्रुव, कल्पेश, कौतिक, पता मुझे तो पता नहीं कौन क्लास में कौन.
Yes, sir.
Yes. Okay. Now, keep one thing in mind. I am saying it is an iterative process. Number of iterations. Number of iterations are hyperparameters. Hyperparameter means user can pass it or user can control it. So let me say in this case, you as a user have given number of iteration 50. It means model will run for 50 times. Okay. And remember, you are building the model for first time. You don't know how many iterations are sufficient. Should I run my model for 5 times, 10 times, 20 times, 30 times, 40 times, 50 times, 100 times? I don't know. So I take some number 50. And after running it for first time, probably I'll decide whether 50 was a good choice or not. Now, this is your cost function or the loss function on your validation data. Let me say on those 1,000 records. This is your cost function or the loss function on your train data. In this case, let me say 7,000 records. So model starts to iterate. And let me say at point number A, till point number A, some 30 iterations have taken place. At point, till your point number A, 30 iterations have taken place. Now, after your 30th iteration, do you notice that in your red curve, errors are increasing? Errors बढ़ते हुए दिखाई दे रहे हैं. In your black curve, the errors are still reducing. What is the black curve? Black curve is the data which you are using for your model building. Basically your train data. The red curve is your validation data, which is not used for your model building. It is only used for your validation. So after your 30th iteration, errors are still reducing in your train data, but they have started to increase in your validation data, or errors have started to increase on the data which was not used for your model building, which means after 30th iteration, your model has started to overfit. Overfit का मतलब क्या होता है? ट्रेन पे एरर कम होता जाए और जो ट्रेन का पार्ट ना हो उस पर बढ़ने लग जाए. So at the starting, I did not knew whether 30 iteration, 40 iteration or 50 iteration, but I have given some random number 50th iteration. But once I draw this diagram, I come to know that after 30th iteration, errors are starting to increase on my validation data also. So what it means? It means that I should stop around 30th iteration. You may stop at 30 or 31 or 29. That is your choice. There is no hard and fixed answer कि तुम्हें exactly 30 पे stop पे जाना है, ठीक है? But wherever you think the errors are starting to increase, that is where you will stop. So this is the concept of your cross validation. Validation भी कर रहा हूँ और cross कर रहा हूँ. Cross means I am not validating on the same data which I am using in my model building. मैं कोई दूसरे data पे validate कर रहा हूँ, which is not used in your model building. Everyone please draw this diagram and make a note that probably after 30th iteration, your model has started to overfit. जब कोडिंग करेंगे तो ये डायग्राम हम लोग ड्रॉ भी करेंगे इस बार.
Done, sir.
Done. So convergence, cost function, gradient distance, caustic gradient descent, learning gate decay, overfitting, cross validation. ठीक है, तो ये स्लाइड तो कवर होता हुआ दिख रहा है. Remember drop out I haven't discussed as of now because you will not understand drop out, but we will discuss as and when the time optimum time comes. Okay. Let's discuss one more thing, and then probably you can take it. So the cost function which we have discussed is your MSC. Okay, cost function which we have discussed is MSC. So normally MSC is used in your regressions. So where your target variable is numeric and continuous. Okay. MSC is normally used in your regression problems where your target variable is numeric and continuous. But your target variable can also be in categories. Okay. So for example, let's say, remember a data set where you are doing the mobile price prediction, high cost, low cost, medium cost. Okay. Whether mushrooms are edible or not. वैसे बहुत सारे scenarios होते हैं binary where your target variable is binary. Okay. Or wherever you have target variable as multi-class. Okay. So over there, probably MSC may not be a very good option. I may try to use my softmax function. Again, softmax. I may try to use my cross entropy. Which is also known as your CE. Now the CE is your cost function, or you can say loss function. Cost and loss function are used to measure what? They are used to measure what? Amount of error. Yes, obviously right answer. Amount of error. Okay. So when your target variable is numeric and continuous, probably you use MSE or some variant of MSE. When your target variable is categorical, the best choice would be your cross entropy. Okay. So cross entropy is a cost function, same as MSE for regression. Aim is to minimize the cross entropy. So basically, whatever may be your cost function, you always try to minimize the cost or the loss. And then only I can say that I have reached the best scenario. So since cross entropy is also a kind of your cost function, loss function, aim is to minimize it. Aim is to minimize it. Okay, now, before I put the formula for cross entropy or anything, let's take 3 scenarios. अब सब लोग ध्यान से देखना. Suppose your target variable takes 2 things, either 1 or 0. Either 1 or 0. Let me say 1 means you are approving the loan is approved, let me say. And 0 means your loan is rejected. Or let me put one more scenario, D1. So these are your actual and prediction probabilities. Remember logistic regression, or whether it is decision tree, it gives you prediction and probabilities also. Yes. So let me say prediction probability for class 1 and prediction probability for class 0. And let me put another thing, final outcome. Ab dhyan rakhna, this is your actual. You are building the model, let me say, or you have built the model, you are doing the testing. Okay. So prediction probability is 0.6 and this is your 0.4. So what would be the final outcome? Final outcome A ke liye kya hoga? 1, wherever the probability is more, it would be marked in the same. Let me say for over here, it was 0.3 and 0.7. What would be the final outcome?
0.
0. Okay. Let's say this was 0.9 and final outcome. And let me say this was 0.7, or let me say 0.75. And so this would be 0.25. Final outcome?
1.
1. Sabko itna samajh mein aa raha? So this final outcome is nothing but your prediction only, right? This is your prediction. Now, if I ask you a question, is there any error? Is there any error when you build your confusion matrix? Confusion matrix जब build करोगे तो क्या तुम्हें कोई error दिखाई देगी? So basically, let me say for record A, it actually belongs to 1 and final prediction is also 1. Model B for person B, actual 0, predicted also 0. Person C actually belong to 1, prediction is also 1. Person D actually 1, belong to 1. So for A, B, C, and D, for all of them, you have given the correct prediction. So probably you will get the accuracy as 100%. कोई error आएगा ही नहीं, right? So if you try to judge the model based upon the confusion matrix, you will get 100% accuracy. अगर 100% accuracy आ गया, it means there is no error. So if 100% accuracy means recall would also be 100 and TPR, recall, precision, F1 सब कुछ 100% रहेगा because there is no error. ठीक है? So in terms of confusion matrix, I can say no error. But do you think there is some error or model can be improved further? बताओ. क्या मॉडल में कुछ एरर है? कैन इट बी इम्प्रूव फर्दर? अच्छा, एक हिंट देता हूं. एक हिंट. आंसर इज देयर आर एरर्स. अब सोचो. और इसीलिए क्रॉस एंट्रोपी आने वाला है. क्रॉस एंट्रोपी का बैकग्राउंड बिल्ड कर. अभी तक क्रॉस एंट्रोपी में एंटर नहीं किया. जैसे होता है ना नॉवल में, पहले हीरो का प्लॉट बिल्ड करते हैं, फिर हीरो को इंट्रोड्यूस करते हैं, वैसे ही कर रहा है. अभी प्लॉट बिल्ड किया है, अब इंट्रोड्यूस कर दूंगा. In terms of confusion matrix, model is the best, 100% accuracy. But can it be improved further? Are there some errors which cannot be captured using your confusion matrix? And वो क्या है? Yeah. Yeah. Correct. Yes. Yes. So yes. So now what he said is absolutely right. Only thing is, शायद तुम लोग समझे नहीं होगे उसका point. See, now for point of, okay, before I enter into that thing, let me say if I ask you one question, out of person A, B, C, D, if you have to give loan to only one person, तो तुम किसको लोन दोगे? C को. Why C को? If you have to give loan to only one person, the obvious choice would be C. Why? Because his probability is the highest. So it means, so person A, person C, person D, they all of them belong to class 1. But within the class 1 itself, the highest probability is of person C. See, basically, for point number at person A, you are giving two answers. You are giving 0.6 also and 0.4. So you are saying that there is a 40% chance that your loan will not be approved. For B, you are giving two answers, 0.3 and 0.7. So you are saying that there is a 30% chance that your loan would be approved. So basically, what is this 0.4, 0.3, or in case of person C, you are saying 0.1 and 0.9. Or in case of person D, you are saying 0.75 and 0.25. In ideal scenario, for person A, the prediction probabilities, and I'm saying ideal scenario where your errors are zero, your prediction probabilities for class 1, and class 0 should have been 1 and 0. So if the loan of person A has to be approved, the best scenario would have been you should have given 100% chance or 1 probability to your class 1 and 0 for your class 0. In case of person B, class 1 and class 0. The best case scenario would have been you should have given 0% to class 1 and 100%, which is nothing but your 1 probability. 1 is nothing but 100% chance. So this is your probability. And this is again your probability. Okay. So इसको कुछ ऐसे देखो. For example, let me say in some school, in small classes basically, when a child is in a small class, you get the answers in grades. देखा है? Grades में आता है. So you may have grade D, you may have grade C, then B, then A, and आजकल A plus का भी जमाना आ गया. So let me say grade D is somewhere around 40 to 60. C is from greater than 60 to 80, or greater than 60 to let's say 70. Then B is greater than 70 to 80, and this is 80 to 90, and this is anything greater than 90. Okay. So let's say if candidate 1 and 2, this got 95% marks and this got 98 or 99% marks. Both of them will belong to category A plus. Final outcome is same, A plus. But if you look in the percentage wise or probability wise, the candidate 2 is much better than your candidate A. Am I right? So in confusion matrix, you only take the final outcome. But when you are doing the prediction probabilities as 0.7 and 0.3, so it means there is some error. You are giving 30% chance to a scenario which is not likely to occur. The ideal scenario should have been either 1 and 0. So you should have given 1 probability and 0 probability. Okay, na? So this is the problem associated with confusion matrix. So remember one thing, confusion matrix cannot be used as your cost function. तुम अपने मॉडल को सिर्फ कंफ्यूजन मैट्रिक्स के बेसिस पे ट्रेन नहीं कर सकते, because it doesn't differentiate between the probability 0.6 and 0.9 or 0.999. In confusion matrix, all of them would be taken as same. So what do? I use the concept of CE, which is nothing but your cross entropy. अब एक काम करो, take your break, and after break we will try to understand what is cross entropy. ठीक है ना? Cross entropy में छोटा सा फॉर्मूला आएगा which is almost similar to your entropy का. ठीक है? Take your break. कितनी देर का ब्रेक चाहिए भाई लोगों? 30 मिनट. अरे बाप रे, 30 मिनट का ब्रेक चाहिए. अच्छा चलो ठीक है, 30 मिनट. Let's meet at 12:50. ठीक है? Take your break. Okay, guys, so let's get started. And I'll share my screen. So it was a pretty long break. Achha. So those who are online, please confirm if I'm audible.
Yes, sir.
Yes, sir.
Thank you. Okay. Right. So let's discuss. So basically we are discussing the cross entropy. It is a cost function, same as MSc for regression. Aim is to minimize the cross entropy. Aim is to minimize the cross entropy. Okay. So what is the formula? Formula is summation minus y log y hat. Okay. This formula is little bit similar to your entropy formula, but confuse nahi karna. Okay. Summation of minus y log y hat, where this is your actual and this is your prediction in probabilities. This is your prediction y hat or y cap. You can say prediction in probabilities. Let's take three scenarios. Scenario number 1, scenario number 2, and scenario number 3. Okay. So in this case, you need to consider that your target variable y is taking 3 values. Y is taking 3 values. And what are these 3 values? These 3 values are your A, B, and C. Y is taking 3 values. So either you belong to class A, class B, or class C. Okay. You belong to class A, B, and C. Before introducing the formula, I am explaining what this problem is. So in the first scenario, do you notice actual? So in the first scenario, it actually belongs to class. It actually belongs to class. Which class? Belongs to class A. Can you notice it actually belongs to class A? Why A? Because हमने उसके सामने 1 डाल दिया, ठीक है ना? It actually belongs to class A. But when you are doing the prediction, you get the probabilities. You get the probabilities, and probabilities are for class A, for class B, and class C. What is the probability for class A? Probability for class A is 0.75. Probability for class B is 0.1. Probability for class C is 0.15. So these are the probabilities. So maximum probability is for your class A. So the final outcome would be your class A. Final outcome would be your class A. So it actually belongs to class A, and final outcome is also class A. So if you use confusion matrix, probably you will get no error. But if I use the cross entropy, to measure my error, इतना याद रखना, using your confusion matrix कोई error नहीं है. But if I use the cross entropy, then the formula I would be using is minus summation y log y. Okay. So it would be minus, I'll not say minus, but minus bahar aa jayega. It would be 1 into log of 0.75. 0.75 क्यों आया? यहां से आया. And ये 1 क्यों आया? Because it actually belong to class 1. ये 1 यहां से आ रहा. ठीक है. And since I am doing a summation, then I will say plus 0 into log of 0.1. ये यहां से आ गया. Plus 0 into log of 0.15. So this thing will become 0 because you are multiplying with 0. And this thing would also become 0 because you are multiplying it with 0. Now, minus, so this would be written as 1 into log of 0.75. जरा log 0.75 की वैल्यू निकालो तो सही बेस ई पे. Import numpy as np and np dot log and pass the value of 0.75. सब लोग पाइथन का यूज करेंगे, कोई अपना मोबाइल कैलकुलेटर यूज नहीं करेगा, neither Google. Import numpy as np and np dot log and put the value 0.75. कितना आ रहा है दोस्तों? हैं?
सर माइनस 0.28.
बहुत सही डायरेक्शन. तुम्हारा मॉडल अभी ट्रेन होना बाकी है. ठीक है. कितना आ रहा है? minus 0.2876 whatever. So yeah, this would be 1 into minus 0.2875 whatever. So this would be minus 0.2875. So minus will become plus and it would become 0.2875. So it is your choice whether you take log base e or base 2. The trend would still be same. ठीक है ना? So I think मैंने log base 2 लिया हुआ यहाँ पे. So let's do one thing. Let me say np dot log base 2 and 0.75. अच्छा तो यहाँ पे कुछ अलग आ रहा है. ठीक है. So 0.125 कैसे आ रहा है? मैंने 0.125 कैसे निकाला? 0.000 log 0.75. Did I use the log base 10? हाँ, मैंने शायद log base 10 यूज किया. But actually it is not log base 10, it is log base e. Log base e रख दो. ठीक है ना? So 0.2875. So final answer comes out to be 0.2875. ठीक है. Now tell me सबका scenario समझ में आया? Thank you, brother.
Yes, sir.
Okay. So whether you take log base 2, log base e or log base 10, the values may change, but the direction would still be same. Direction would still be same. So this is what my scenario 1 is. Now let's come back to this scenario. यहाँ से value हटा. Let's remove these values so that it should not confuse you. Okay. Now, let's consider the scenario 2. In scenario 2, it actually belongs to class 1. ध्यान से सुनना सब लोग. It actually belongs to class 1. And that is why you have put, sorry, it actually belongs to class A. And that is why you have put 1 over here. It doesn't belongs to class B and C. But when you have done the prediction, predictions are in probabilities. So the highest value is for your class B. It means final outcome would be in for your class B. Barabar? It actually belonged to A, but the final outcome is B. In scenario 1, it actually belonged to A and final outcome was also A. In scenario 2, it actually belonged to B and the final outcome is, sorry, it actually belonged to, my mistake. It actually belonged to, it actually belonged to A, but the final outcome was B. It means scenario 1 is better than scenario 2. फिर से statement बोलता हूं. It means scenario 1 is better than scenario 2, or it means scenario 2 is worse than your scenario 1. It means scenario 2 में ज़्यादा errors होंगे. It means scenario 2 has more error compared to your scenario 1. Let's do the same thing. Let's find the cross entropy for scenario 2. So what I will do is I will say summation of minus y log y hat. Previously I had taken the base e, so इस बार भी base e ले लेते हैं, ठीक है ना? So what I'll do, I'll say summation minus 1 into log of 0.3, ठीक है? Plus 0 into log of 0.6 plus 0 into log of 0.1. So इन दोनों को तो हटा देते हैं because you are multiplying with 0, correct? Now minus 1 into log of 0.3. So it comes out to be minus 1.2. So minus minus will become plus. So it becomes your 1.2039, whatever. ठीक है, सबको समझ में आ रहा है? So can you notice the value, if the error is more, then cross entropy is also increasing. Cross entropy बढ़ती हुई दिख रही है.
Sir.
Yes.
Why did you take -1 here? Minus.
No,
y.
sorry. Minus ये वाला minus sign को ignore कर दो. Ignore this thing. But even so, when you take log of minus, when you take log of 0.3, तो log of 0.3 तो minus में आएगा ना? Minus 1.2.
Yes, sir. Minus minus.
अब minus minus तो plus हो जाएगा ना?
Yes, sir.
See, basic ये minus sign लिया ही इसलिए गया है because तुम्हारी minus की values plus में आ जाए. That is why purposefully minus sign attach किया गया. Because whenever you are taking a log of a number which is less than 1, answer would always be in minus. So to convert that minus value into plus, we are using that later on minus sign. And ये same concept हमने entropy में भी use किया था, if you remember. Now let's talk about the third scenario. So in third scenario, it actually belonged to class 1. Sorry, it actually belonged to class A. It actually belonged to class A. And what is the final outcome? Final outcome is also class A. But do you notice that this is the ideal scenario? Ideal scenario with 0 error. It actually belongs to class A, and when the predictions have been done, it is giving full chance or full 100% chance, or you can say probability of 1 to your class A. B and C के लिए उसने 0 probability दे दी है. तुम 1 को belong करते थे, and with 100% confidence, it is saying that you belong to class 1. Now, if I apply the same formula, summation of y log y hat, then it would be minus. What I will do, I'll say 1 into log 1. Why 0? यहां से 1 आएगा ना, ये वाला 1 जाएगा ना, ठीक है? Plus 0 into log whatever 0 you can say, and plus 0 into log 0 whatever. So these things will become 0. And log 1, चाहे base e हो, चाहे base 2 हो, चाहे base 10 हो, log 1 is always 0. So 1 into 0 is again 0. So do you notice when in the ideal scenario cross entropy becomes 0? Ideal scenario the cross entropy becomes 0 and इसीलिए देखो यहाँ पे लिख भी दिया है. So 0 when the prediction is perfectly correct. And that is why your cross entropy की range क्या हो जाएगी? It can go from 0 to infinity. 0 when it is the ideal scenario with no errors. And infinity, if you keep on increasing error, it can cross the boundary of 1 and it can go anywhere. समझ में आया? So I am not very much recommending this formula to be remembered, but at least concept wise, please remember one thing. Why are we using cross entropy and why confusion matrix cannot be used to train the model? ठीक है ना? Confusion matrix के लिए 0.9 और 0.95 दोनों same. But for cross entropy, 0.95 and 0.9 are two different things. ठीक है ना? Confusion matrix के लिए 0.51 and 0.99 भी same है. But in real terms, 0.51 probability and 0.99 probability, one is a very good scenario, another is a very confusing scenario. यहाँ तक सबको clear है?
Yes, sir.
Yes. Okay, ठीक है. And highly recommended, guys. Please एक बार go through these recording sessions once more. No matter how much attention you are paying today in this class, but there is 100% chance that after 2 days you will start getting confused. And ऐसा नहीं कि तुम लोग कंफ्यूज हो रहे हो तो कोई बहुत बड़ी बात है. इंडस्ट्री में you directly use cross entropy, you directly use the function, but उसके पीछे की मैथमेटिक्स वर्किंग प्रोफेशनल को भी भूल चुका होता है वो. ठीक है? तो तुम लोग भी भूल जाना, बट लेट से आज से 1 साल बाद 2 साल बाद जब पहली नौकरी लग जाए तो तुम लोग भूल जाना, कोई दिक्कत नहीं है. ठीक है? लेकिन इंटरव्यूज तक थोड़ा सा याद करके चलो. अच्छा चलो, क्रॉस एंट्रोपी हो गया. कीप वन थिंग इन माइंड, न्यूरल नेटवर्क अभी स्टार्ट होना बाकी है. अभी सब हम लोग खेल रहे हैं. ठीक है? एट द एंड आई विल कंबाइन ऑल दीज कंसेप्ट जो हम लोग पिछले 2 क्लासेस से सीख रहे हैं. क्रॉस एंट्रोपी, सॉफ्ट मैक्स, ग्रेडिएंट डिसेंट, लॉस, सब कंबाइन कर देंगे. रेलू सब कंबाइन करके एक नेटवर्क ड्रॉ कर देंगे हम लोग. ठीक है? सो प्लीज कीप ऑन रिमेम्बरिंग द कंसेप्ट. नाउ लेट्स टॉक अबाउट द सॉफ्ट. So before I start talking about soft math, जरा मेरे को ये बताओ, तुम लोग इतने सब तो इंटेलिजेंट हो तुम लोग, क्या सिग्मॉइड याद है?
Yes, sir.
याद है? अच्छा चलो, सबको याद है? मैं किसी का नाम ले लेता हूँ जो क्लास में नहीं. कार्तिक कौन है? तुम हो. ठीक है. श्रद्धा पाटिल, ठीक है, छोड़ दो. प्रथमेश इधर ही है. ऋतुजा कौन है? पता नहीं. अच्छा, सौरभ कौन है? श्रेयस कौन है? श्रेयस ऑनलाइन में है? ठीक है, आज श्रेयस के नाम की लॉटरी लगी. श्रेयस तुम बताओ व्हाट इज सिग्मॉइड फंक्शन. श्रेयस, कैन यू हियर मी? श्रेयस कुंभार.
Yes.
टेल मी समथिंग अबाउट द सिग्मॉइड फंक्शन. 1 मिनट का टाइम ले लो, अपने नोट्स वोट्स पलट लो, फिर बताओ. मुझे पता है टॉप ऑफ द माइंड शायद नहीं हो. टॉक समथिंग अबाउट द सिग्मॉइड फंक्शन.
Sigmoid range is 0 to 1.
Sigmoid is from 0 to 1. Okay. Anything else? What is the equation do we use over there?
It is a large negative number or a large positive number.
large negative number, large positive number. Okay. अच्छा अच्छा चलो जो क्लास में उनमें से कोई जन बताओ प्लीज.
It has a S-shaped curve.
It has a S-shaped curve. That's a good answer. Can you add something more to that, please?
Sir, in that we plot P to ln of P by Q.
P of ln P by Q. Yes. So that is a equation. Okay, fair enough. So in sigmoid, what do we do? So sigmoid basically मैं कुछ ऐसा सुनना चाह रहा था that sigmoid function is used when your target variable is binary. ठीक है ना? तो जब भी किसी को बताओ ना तो ऐसे बताओ कि वो समझ जाए सामने. That your target variable is binary. It has either 1 or 0. If it is not 1 and 0, we convert it into 1 and 0. So let's say it is 1 and 0. So probability of 1 we are saying is P. Probability of 0, let me say I'm saying Q. So equation क्या होती है? ln P by Q, or you can say ln P upon 1 minus P. The range of P can be from 0 to 1, including 0 and 1. And the range of 1 minus P, nature of the formula says it would be from 0 to 1, including 0 and 1. So basically we say that P plus Q would be equal to 1, where P is less than or equal to 1 and greater than or equal to 0. And same thing holds true for your Q also. Okay? So P plus Q is equal to 1 and P is greater than or equal to 0 and less than or equal to 1. And same thing holds for your Q. If you know P, in a way you also know your Q. So once I subtract कर दो Q की value आ जाएगी. ठीक है ना? So basically P plus Q creates an exhaustive event. ये एक exhaustive event होता है. Exhaustive means there is nothing outside it. The value of P and Q should be between 0 and 1 and they should add up to 1. अगर 1 को add नहीं कर रही तभी भी problem है. ठीक है ना? They should be between 0 and 1 and they should add up to 1. ठीक है? So when you draw this curve, your curve would look something like this. ये x-axis हो गया, ये y हो गया. And obviously this point is your origin. Let me say 0, 0. 1 पे एक line ले ली. ठीक है ना? 0.5 पे एक boundary ले ली. ठीक है? So if the value is less than 0.5, if the value is less than 0.5, it belongs to class 0. If it is greater than or equal to 0.5, it belongs to class 1. ठीक है ना? So when the value of P goes from 0 to 1, you get this type of curve. ठीक है? अच्छा, एक सेकेंड में सॉफ्ट मिक्स कर रहा हूं. ठीक है. नाउ हमने कौन सा फॉर्मूला यूज किया? हमने यूज किया ln P by Q, और यू कैन से ln P अपॉन 1 minus P. ये एक फॉर्मूला है. सिमिलरली देयर इज अनदर फॉर्मूला 1 upon 1 plus e power minus x. ठीक है? Now let me say x is a rational number. ठीक है? ये एक rational number है. It can take any value. It can take any value from, let's say, minus infinity to plus infinity. Imaginary values नहीं लेगा. Real, कोई भी real number ले सकता है. So can I write this formula something like this? E power minus x is nothing but 1 upon e power x. बराबर? ठीक है? So if you agree to this, मैं इसको फिर ऐसे लिख दूंगा. So LCM would be e power x. So it would be written as 1 plus e power x upon e power x. तो ये वाला e power x ऊपर चला जाएगा. E power x upon 1 plus e power x. बराबर? E power x upon 1 plus e power x. So this equation is also the equation of logistic regression. ठीक है, तुम ये यूज करो या ये यूज करो, एक ही चीज है. This is also the equation of logistic regression. Achha, now let's do one thing. Let's take the values of x and e power x upon 1 plus e power x. ठीक है. So x can take any values from minus infinity to plus infinity. Suppose karo if x is 0, then what would be this value? So this value would be e power 0 upon 1 plus e power 0. E power 0 is nothing but 1.
1 by 2.
So 1 upon 1 by 2. So can I say 0.5? हाँ या ना? एक काम करते हैं ना, फॉर्मूला डाल देते हैं. ठीक है, लेट मी से, अरे बाबा, लेट मी से x एंड फिर हमने क्या यूज किया है, np डॉट एक्सपोनेंशियल x डिवाइडेड बाय 1 प्लस np डॉट एक्सपोनेंशियल x. ठीक है, x की वैल्यू कर देते हैं 0. 0.5 आ गए. ठीक है, यहाँ पे 0.5 लिख देते हैं. नाउ लेट मी से व्हेन द वैल्यू ऑफ x इज 1. अब तुम लोग से मेहनत नहीं करवाऊंगा, मैं खुद ही चेंज कर दूंगा. 0.73. लेट मी से वैल्यू ऑफ x इज 10. और पहले 2 को ले लेते हैं. लेट मी से द वैल्यू ऑफ x इज 2. तो यहाँ पे डाल दो बाई 2. क्या हो गया? 0.88. So do you notice when x is increasing, value of this is also increasing. Now let me say I put it as 10. 10 डाल देते हैं. 0.9999 something. कितने बार 9 है? 4 बार 9, 54. 11 कर लेते हैं. और लेट मी से 20 कर लेते हैं. अरे ये मेरा कंट्रोल जा रहा है बार-बार. Do you notice when x is, so whether x is 10, 9, whatever, so at x equal to 10, value is 0.99. So do you notice from 0 till 10 or from 0.1 to 10, values increased very fast. But उसके बाद रुकती हुई दिख रही है. Now तुम कोई भी नंबर ले लो, तुम यहाँ 2000 भी ले लो, 200 भी ले लो, या 2000 ले लो, देखते हैं. नया आ गया. ठीक है, कैलकुलेट नहीं कर पा रहा है. ठीक है, या लेट मी से 230 ले लो. Values are bounded by 1. 1 को breach नहीं करेगा. And why it will not breach 1? Answer is very simple, because 1 plus e power x would always be greater than or equal to e power x. So जब denominator numerator से बड़ा है तो value 1 को क्रॉस कभी करेगी. बराबर है ना? ठीक है. So can I say the upper bound becomes your 1? And do you remember when I was using ln p upon q, this was also upper bounded by 1? याद आता है सबको? तुम कुछ भी वैल्यू बढ़ाओ, 1 को कभी ब्रीच नहीं करती थी. ठीक है, the same thing will happen over here also. Now let's start decreasing the value. ठीक है, values को हम जरा decrease कर देते हैं. So I started from 0. Let me say I am putting it as -1. I put it as -1. अब देखते हैं भाई क्या होता है. 0.26. So values start to decrease. Let me say 2, -2, -10. So e minus 0.5, it means value has gone almost close to 0. So do you notice? So can I say when x is moving towards infinity, e power x upon 1 plus e power x is moving towards 1. When x is moving towards minus infinity, e power x upon 1 plus e power x is moving towards 0. And if you draw the graph of this and this, it would again be your same S curve. It would again be your S curve. अच्छा, ऐसा क्यों हो रहा है? It is very simple. Let me say, so Siddharth ने कुछ message भेजा. अच्छा, he was answering the sigmoid function. Okay, ठीक है, fair enough. Suppose करो number is 100, and if you divide it by 2, you get 50. If you divide it by 3, you get 33. There is a very big difference. But if you divide it by 99, it is 1.001. And if you divide it by 101, now do you notice? Number जितना बढ़ता चला जाएगा, the difference in the output would be smaller and smaller. ठीक है ना? So when you divide it by 99, answer is 1.01. When you divide it by 101, answer is just 0.99. Or if you divide it by 100, answer would be just 1. So what is the difference between 99 and 100? The answer is, difference is only 0.011. But when you divide it by 3 and when you divide it by 2, there is a big difference. That is where the large numbers come into the play. And again, keep one thing in. So the same concept I am using over here. So what is the formula for sigmoid function? Can I say sigmoid function में हम ये formula भी use कर सकते हैं? E power x upon 1 plus e power x. But this formula can be used only when your y is binary. So sigmoid can be used only when your y is binary. Now, तुम लोगों ने शायद एक चीज देखी होगी, पाइथन में लॉजिस्टिक रिग्रेशन के कुछ वेरिएंट्स आते हैं. Some variants may work when your y is not binary. Not binary means it can have more than 2 classes. एक क्लास तो कभी होगा नहीं, otherwise मॉडल बिल्ड करने की जरूरत ही क्या है? ठीक है. So you cannot have less than 2 class. Either you will have 2 or you will have more than 2. So when you have more than 2 classes, sigmoid cannot be used. That is for sure. Sigmoid हमारे काम का नहीं रहा when you have more than 2 classes. So sigmoid cannot be used. Sigmoid use नहीं हो सकता, but a variant of sigmoid, or I will say sigmoid is a variant of something. Sigmoid cannot be used, but softmax can be used. Sigmoid cannot be used, but softmax can be used. Background build हो गया. Why do we need softmax? Because when my y is not binary, then sigmoid is of no use. I need to use something similar to sigmoid, and that is nothing but your soft. Now let's try seeing कि भाई ये softmax है. ठीक है. अगर इतनी चीज क्लियर है तो अब softmax पे आ जाओ. Okay, let me say your y can take 3 values, A, B, and C. Y is a multi-class. It can take 3 values, A, B, and C. So event A can occur in 11 different scenarios. Event B can occur in 12 different scenarios. Event C can occur in 13 different. This is 12. This is 13 scenarios. Okay. सबको सिनेरियो समझ में आता है? सो सपोज करो एक इवेंट है. The event A can occur in 11 different scenarios. So there are 11 different scenarios where your loan can be approved. Suppose karo tumhari income is more than this thing and your credit risk is less than 0.1 or 0.2, then also your loan can be approved or whatever. Event B can happen in 12 different scenarios. Event C can happen in 13 different scenarios. Then can you tell me what would be the probability of event A, probability of event B, and probability of event C? Base. So you are saying probability of 11 can be 11 divided by the total number of events. 11 plus 12 plus 13 जो हमें probability में सिखाया गया है, लेकिन उस टाइम ये नहीं सिखाया गया कि ये इसका प्रॉब्लम क्या है. आज तुम वो सीखोगे. ठीक है. अब तुम सबकी मैथमेटिक्स तो अच्छी है, जरा मेरे को आंसर निकाल के बताओ. यूज योर पाइथन एंड टेल मी द वैल्यूज. ए की प्रोबेबिलिटी कितनी, बी की कितनी और सी की कितनी. ऐसे चाहूं तो मैं भी निकाल सकता हूं, बट मैं आई एम जस्ट वेटिंग फॉर यू गाइस टू पुट एन एफर्ट. अपना पाइथन यूज करो, एबीसी की वैल्यू डालो, एक फॉर्मूला डाल दो, बस खत्म. सो ए की वैल्यू कितनी है? 0. बी की
0.33.
एंड इसकी ऑब्वियसली इन दोनों से हटा दो तो 0.36 आ जाएगी. 0.36 समथिंग. अच्छा, नाउ इफ यू ऐड दीज थ्री नंबर probably you'll get answer as 1. ठीक है ना. एक काम कर लेते हैं हम लोग, यहाँ पर डाल देते हैं वैल्यू ए बी सी. ए की कितनी है? 10, बी की है 11 और सी की है, अच्छा 11, 12, 13 है. ठीक है. So probability of A would be A divided by A plus B plus C. ठीक है. तो this is point of A. B की कितनी हो जाएगी? इतनी. C की कितनी हो जाएगी? इतनी. ठीक है ना. So A upon A plus B plus C, B upon A plus B plus C, and C upon A plus B plus C. If you add all these three numbers, the answer would be 1. So probabilities are within 0 and 1 and they add up to 1. So the nature is almost same as your sigmoid. Nature तो same आ रहा है. ठीक है. So you get these probabilities. So which is the highest probability? Highest probability कितनी है? 0.36. So final outcome क्या होना चाहिए? What would be the final outcome? किस क्लास को बिलोंग करेगा? C. So you will say that final outcome is class C. What is the nature of the formula I have used? I have used A upon A plus B plus C, or you can say B upon A plus B plus C, or C upon A plus B plus C. Final outcome is C, and probability of event C is 0.36. अच्छा. Any doubt, any questions? यहाँ तक कोई doubt, कोई question है? नहीं. Do you see any issue in these calculations or in final outcome, or I'll say in probabilities? ठीक है. हाँ बोलो आंसर. Values are very close to each other. That is one very good observation. I must appreciate it. So one problem, एक जो पहला problem हमें दिखता है, that predicted probabilities, or you can just say probabilities, are very close. Probabilities are very close. This is one good observation, and it's a very good point. 0.30, 0.33, 0.36. Probabilities are very close by, so that decision making is very tough. सिर्फ 3% का difference है. Any other problem do you notice? एक और बड़ा प्रॉब्लम है. मेरे सेंटेंस को ध्यान से सुनो और देखो क्या कुछ प्रॉब्लम पकड़ में आता है. The final outcome is event C, and probability that event C will occur is 0.36. I repeat my statement. The final outcome is event C, and probability that event C will occur is only 0.36. अब समझ में आया?
Sir, the data means like only 0.36 is like correct probability, but remaining is all error. Error is large.
Yes. So I am saying the event C will occur, but उसकी occur होने की probability 50% से भी कम है. So suppose करो, वैसे तो ये एग्जांपल लेना नहीं चाहिए, इंडिया हार गई. Suppose करो ऐसे इंडिया एंड पाकिस्तान का मैच है, ठीक है, and I say India will win the match. India will win the match, and probability that India wins is only 0.36. तो क्या ये स्टेटमेंट जमता है? You are saying a event will occur, but the chances of occurring are less than 50%. So it means there are events which are having, or combination of events which can occur, जिनका chances are more than 50%. Then why are you not saying that combination of A and B can occur instead of C? By 50% से ज्यादा हो तभी तो बोलना अच्छा लगेगा ना that this event will occur. You are saying event C will occur, but chances are even less than 50%. So basically two issues are coming over here. One is the probabilities for each classes are very nearby. Decision making is tough. And the final outcome is having a probability which is even less than the 50%. ठीक है? So basically जब तुम्हें स्कूल में प्रोबेबिलिटी सिखाई गई तो ऐसे ही सिखा दी गई कि प्रोबेबिलिटी आ जाएगी A/A + B + C. इवेंट A के इतने सिनेरियोज हैं, B के इतने सिनेरियोज, C के इतने सिनेरियोज, तो A की प्रोबेबिलिटी कितनी होगी. बट उसका प्रॉब्लम नहीं बताया गया, और जब प्रॉब्लम ही नहीं बताया गया तो सोल्यूशन बताने का तो फिर सवाल ही पता नहीं होता. अब सोचो, so now can I say that people are clear with what is the problem associated? What is the problem associated if you use a blank formula of A + B + C? इसका प्रॉब्लम सबको समझ में आया? दो बेसिक प्रॉब्लम, probability is nearby and even the highest probability may be less than the 50%. तो हम क्या करेंगे, इसी फॉर्मूले को लेंगे और हल्का सा घुमा देंगे. कैसे घुमाएंगे? e⁴ upon e⁴ plus e⁴b plus e⁴c. This will become your probability of A. Probability of B would be e⁴b upon e⁴a plus e⁴b plus e⁴c. Basically, the denominator will still remain the same. Probability of C would be e⁴c upon e⁴a plus e⁴b plus e⁴c. तुम बताओ, तुम्हारा जूपिटर नोटबुक ओपन हो गया? आप जरा निकालो, तीनों के वैल्यूज निकालो. ये वाला रो निकालेगा A का, ये वाला B का निकालो, और ऑनलाइन वाले C का निकालो. ऑनलाइन पीपल फाइंड C. My right hand side find for B, my left hand side find for A. I hope people are using Jupyter Notebook. ABC की वैल्यू डालो, np.exponential A divided by np.exponential B. For A it is how much? 0.09. ओके, ठीक है. B की राइट हैंड साइड ऑनलाइन से कुछ नाम और उठाते हैं. ऋतुजा, व्हाट अबाउट प्रोबेबिलिटी ऑफ C? किसका? तो तुमने C का भी निकाल लिया. 0.66. तो इसकी आ जाएगी 0.30 और कितनी आ जाएगी 0.324। अरे बी वालों की निकालो ना, तुम लोग पता नहीं क्या कर रहे हो। ए बी सी की वैल्यू ऑलरेडी डिफाइंड है, सो प्रोबेबिलिटी ऑफ ए वुड बी np डॉट एक्सपोनेंशियल a divided by np dot exponential a plus np dot exponential b plus np dot exponential c। 0.90 तो उसने सही बोला था। सो प्रोबेबिलिटी ऑफ b .244, प्रोबेबिलिटी ऑफ c कितना टाइम लगता है यार 0.66, so 0.24, 0.66, 0.24 and 0.66, and probably if you add all these three numbers, you will get answer as one only, 0.66, 0.24 and 0.099. So if you do that calculations, let's say 5 to 6 digits after decimal, answer would again be 1. Okay, now, so these are the probabilities. Now, do you notice the problem associated with a upon a plus b plus c has vanished? Now, do you notice the final outcome would be your event C? No, still, but this time event C has a very high probability. Instead of 0.36, it has gone to 0.66. It has gone to 0.66. Now, if I say event C will occur and the probability is 66%, that one problem has vanished. And do you notice there is a big difference between the probabilities? पहले probabilities के बीच में difference कितना था? Only 0.03. Now there is a big difference. In percentage wise, it is 9%, it is 24%, and this is around 66.7%, whatever. ठीक है ना? So this has happened. So that is why we take the exponential. इसको ऐसे याद रखो, मैंने पहले भी बोला है that why do we take a square? 12 is just greater than 11. It is just greater than 11. But e power 12 is much greater than e power 11. ठीक है, करके देख लो. np dot exponential 11. It is 59,874. If I take np dot exponential 12, it is 1,62,754. So if you notice, the difference is somewhere around 2.5 का difference आ गया. So 250 percentage points का difference आ जाएगा. So if अगर मैं इसको divide करूं, np dot exponential divided by np dot exponential 11, तो देखते हैं कितना difference आता है, 2.71. And if you divide 12 by 11, answer is 1.09. So 1.09 से सीधे 2.7 चला जा रहा है. So around 2.7 टाइम का डिफरेंस आ जा रहा है. एंड ऑलमोस्ट शायद इतनी वैल्यू होती है तुम्हारी ई की, 2.718. ठीक है ना? तो उसने ई की वैल्यू दे दी है. ठीक है ना? सी, सो डू यू नोटिस, डू यू गेट वन पॉइंट? व्हाट इज द पर्पस ऑफ टेकिंग exponential? And guys, this formula which I have used, probability of A is equal to e power A upon e power A plus e power B plus e power C. Let me say e power A plus B plus E plus C को, इसको हम मान लेते हैं e power Z, or you can just say Z. So probability of A is equal to e power A upon, let me call this number as Z. Okay, so Z. Probability of B would be e power B upon Z. probability of C would be e power C upon Z. And do you notice by the symmetry, even if it is A comma B comma C comma D comma E, this formula can still be used. Nature of the formula can still be used. ठीक है ना? So whether it is binary, whether it is 3 classes, 4 classes, 5 classes, you can still use this formula. And this formula is nothing but your softmax. ये तुम्हारा softmax है. ठीक है? This is nothing but your softmax. So softmax can be used for your binary problems also, and they can be used when it is more than 2. अच्छा, किसी के माइंड में ऐसा तो नहीं आया कि मैंने आर्टिफिशियली प्रोबेबिलिटी बढ़ा दी है, जानबूझ के प्रोबेबिलिटी बढ़ा दी, इतनी होनी ही चाहिए थी, तभी हो गई? माइंड में आया किसी को? So basically what I'm asking is, so without using softmax, probability of C was कितना था? 13 upon 11, नहीं 11, 12, 13 था, 10, 11, 12 था, 11, 12, 13 था ना? So आंसर आया था around 0.36 after softmax. आफ्टर सॉफ्टमैक्स प्रोबेबिलिटी ऑफ सी को हमने यहाँ पे सी आना चाहिए. इट वाज ई पावर सी डिवाइडेड बाय ई पावर, और लेट मी से प्रोबेबिलिटी ऑफ सी वाज, लेट मी पुट इन नंबर्स, ई पावर 13 डिवाइडेड बाय ई पावर 11 प्लस ई पावर 12 प्लस ई पावर 13. बराबर? यही है? सही है या कोई टाइपो एरर है? ठीक है ना? And then answer came out to be 0.66. So does a question comes that by using E, I am artificially increasing the probability? आता है? तो क्या कुछ गड़बड़ हो गई है? E यूज नहीं करना चाहिए? Just because मुझे probability बढ़ानी थी इसलिए मैंने exponential ले लिया, ऐसा क्वेश्चन माइंड में आता है? आता है? अगर आया तो अच्छी बात है, बट सोचो ऐसा क्यों कर रहे हैं हम लोग? इस क्वेश्चन का आंसर, that if you are thinking that probability has been artificially increased, question is a valid question, but इसका आंसर मैथमेटिक्स में नहीं मिलेगा. इसका आंसर तुम अपने जो रियल लाइफ में झांक के देखो तो आ जाएगा. Data science में क्या है? Data is coming from real life, so whatever you see in your real life, probably you would be seeing in your data, and same thing would be following in your model also. In actual terms, the values of A was 11, 12, and 13. So scenario A can happen in 11 ways, B can happen in 12 ways. And if, sorry, I'll not say scenario, but event A can happen in 11 ways, event B can happen in 12, and event C can happen in 13 ways. But when I go with exponential, then I can see a big difference between A, B, and C. अगर हम B and C को compare करें, so there is only one more favorable way in which event C can happen. कभी तुमने ऐसा सुना है कि a small change in your life can result in big changes? एक छोटा सा चेंज तुम करो, उसके इम्प्लीकेशंस बहुत बड़े हो सकते हैं. ठीक है? एक एक्स्ट्रा, सपोज करो तुमने एक बैट्समैन को हटाया और उसकी जगह एक ऑलराउंडर को डाल दिया, तो चेंज तो छोटा सा है, बट हो सकता है the matches which you are losing by a very thin margin, you start to win them. सपोज करो तुमने अपनी टीम का जो फिटनेस लेवल था उसको थोड़ा सा इंक्रीज कर दिया. So by the end of the match, your team was getting very tired, but अब वो tired नहीं होती है. So it was losing the close matches, but now it may start to win the close matches. And at the end, you may see the number of wins and losers में काफी बड़ा difference आता हुआ दिखाई देगा. So a small change in your X or in your input may result in very large change in your output. So कहने को तो B and C में सिर्फ 1 यूनिट का डिफरेंस है, but the probability would not be same in real life. हो सकता है C के occur होने के chances are much more. That is what this formula tries to capture. ठीक है. Let me know any doubt, any question. अच्छा, सब लोग अपना अपना माइंड जरा ब्रेन चेक करो, देखो कितना एब्जॉर्ब कर सकता है. और मॉडल कन्वर्ज हो गया है या थोड़ा और लर्न कर सकते हैं? बिकॉज अब थोड़ा डिफिकल्ट, अभी तक तो सब हल्के हल्के चीजें थी, अब थोड़ा सा डीप में जाएंगे. तो उन्होंने क्वेश्चन का आंसर नहीं किया गाइस, ऑनलाइन ऑफलाइन सब लोग. अच्छा, कोई आंसर करने को रेडी नहीं है. वैष्णवी तुम बताओ.
Yes, sir.
यस सर मीन्स मतलब तुम मुझसे क्वेश्चन. ओके ठीक है, कोई बात
Yes, sir.
नहीं.
In kind of like question, sir.
ठीक है, सिद्धार्थ ने बोला है बस सर. अच्छा ठीक है चलो. अच्छा ठीक है चलो, कोई बात नहीं. सी आई अंडरस्टैंड न्यूरल नेटवर्क के अपने थोड़े से चैलेंजेस हैं, सो आई विल नॉट गो विद एनी न्यू कंसेप्ट और सब कंसेप्ट, बट कल के लिए एक बैकग्राउंड बिल्ड कर देते हैं कि हम लोग कल क्या करने वाले हैं. ठीक है, वैसे हमारे पास टाइम है, बट ठीक है, फेयर इनफ. कल ना हम लोग ये काम करने वाले हैं. कौन सा काम करने वाला है? स्लाइड नंबर 9. ठीक है, आई रिमेम्बर मैंने बोला था ना कि जिस दिन तुम ये समझ जाओगे उस दिन समझोगे तुम न्यूरल नेटवर्क समझ में आ रहा है. जरा अब एक बार वापस पढ़ो, देखो क्या थोड़ा सा ज्यादा समझ में आता है या अभी भी प्रॉब्लम है? अभी भी प्रॉब्लम तो है, बट क्या थोड़ा सा इंप्रूव हुआ है? एक्टिवेशन फंक्शन अब समझ में आ रहा होगा, ठीक है ना? व्हाट इज एक्टिवेशन फंक्शन? अभी कई टाइप के एक्टिवेशन फंक्शन आएंगे. सिग्मॉइड भी एक टाइप का एक्टिवेशन फंक्शन हो सकता है, ठीक है, but I'll just refrain from introducing that thing. So artificial neuron is a mathematical function based on model of biological neurons. So biological neurons means the cells in your brain where each neuron takes the input. weighs them separately, does the summation, and the summation is passed through a non-linear function, activation function, to produce the output. Another name of neuron is perceptron. ठीक है. So tomorrow when we'll meet ना, we will see ये जो diagram तुम्हें mesmerizing लग रहा है, ये जो diagram है ना, हम लोग इसे understand करने की कोशिश करेंगे कि ये what is this, how does the information flows from left to right, and how do the errors flows from right to left, जिसको कि हम लोग बोलते हैं back propagation. ठीक है. Then what we will do is we will combine everything. We will combine our ReLU also. We will combine our stochastic gradient descent. We will combine what is our iteration, what is our learning rate. We will combine everything, and this combined knowledge is needed to understand this network. अभी तक मैंने देखो कहीं पे भी न्यूरॉन का यूज करा है क्या? कहीं यूज नहीं करा मैंने. Everything which we studied, I studied in silos. रेलू अलग से समझा, स्कॉस्टिक ग्रेडियंट डिसेंट सब कुछ. अब टाइम आ गया कि उन सबको कंबाइन करके एक नेटवर्क, एक घर बना देंगे हम लोग. एंड हाउ दिस मॉडल विल गेट ट्रेन. सो प्लीज गाइस, आज घर जाने के बाद ना और कल क्लास में आने से पहले जितने भी कंसेप्ट हमने पढ़े ना, वो सब रिवाइज करके बिल्कुल टॉप ऑफ द माइंड में, कि जब मैं बोलूं एलआर और हाई एलआर तो तुम्हें समझ में आना चाहिए. या इफ मैं बोलूं कि व्हाट इज सॉफ्टमैक्स फंक्शन, आई विल यूज सॉफ्टमैक्स फंक्शन, तो तुम्हें समझ में आना चाहिए व्हाट इज सॉफ्टमैक्स, व्हाट इज एमएससी, व्हाट इज स्कॉस्टिक ग्रेडियंट डिसेंट, सारी चीजें समझ में आनी. देन प्रोबब्ली यू विल अंडरस्टैंड दिस नेटवर्क. ठीक है ना. खेलने के लिए तुम लोग को एक चीज दे देता हूँ. घर पे जाओ, थोड़ा सा खेलो. क्या खेलना था? टेंसरफ्लो प्लेग्राउंड. सब लोग गूगल पे जाओ एंड जरा इसको सर्च करो, टेंसरफ्लो प्लेग्राउंड. ये क्या हो गया? ये विसर्जन आज क्यों हो रहा है? वो तो कल हो जाना था ना. चलता है क्या? अच्छा हाँ, कल हम लोग कोडिंग कर पाएंगे? कर लेंगे, कोडिंग कर लेंगे. ठीक ठीक. बेसिकली फॉर न्यूरल नेटवर्क देयर आर मेनी फ्रेमवर्क्स. इसका कुछ नोट करने की जरूरत नहीं. देयर आर मेनी फ्रेमवर्क्स. वी वुड बी यूजिंग अ टेंसरफ्लो. हम लोग टेंसरफ्लो फ्रेमवर्क यूज करेंगे. दिस इज प्रोवाइडेड बाय गूगल. ठीक है. वैसे ही एक और फ्रेमवर्क है, दैट इज योर PyTorch. दिस इज प्रोवाइडेड बाय फेसबुक. And then the list is, I'll not say infinite, but endless तो है. Then you have your MNet, you have your H2O, बहुत सारे. But the best one is this one. It captures around 95% of the market. But somewhere PyTorch also gives better result than your TensorFlow. Personal experience है. People may agree, may not agree. But हम देखेंगे TensorFlow. ठीक है. TensorFlow is a framework. Framework for building your neural networks. ठीक है. Now we know that neural network is like your brain, and you cannot interpret your brain. So whenever you do a calculation, can you tell brain के किस सेल ने क्या कैलकुलेशन किया था? आंसर इज नो. तुम्हें नहीं पता ब्रेन में क्या चल रहा है. सुन तुम मेरी बात रहे हो, सोच कुछ और रहे हो, पता नहीं है ना. सो यू कैनॉट इंटरप्रेट कि तुम्हारे ब्रेन में चल क्या रहा है. ठीक है. सो सेम थिंग, न्यूरल नेटवर्क्स कैनॉट बी इंटरप्रेटेड. सो व्हाट डिड गूगल डू? गूगल ने एक प्लेग्राउंड बना दिया टू जस्ट गिव एन आइडिया. एक आइडिया देने के लिए कि न्यूरल नेटवर्क कैसे इंटरनली कैसे काम कर रहा हूँ. अब देखो यहाँ पे ये प्लेग्राउंड है. मन करे तो खेलना, मन करे तो नहीं खेलना, तुम्हारी मर्जी है. अच्छा, on the left hand side, can you notice it is written which data set to use? दिखता है सबको? वैष्णवी तुमको दिख रहा है?
Yes, sir.
And बाकी लोग भी. So to see, so which data set to use?
Yes.
So can you notice there are 4 data sets? 4 data set दिखते हैं.
Yes.
ठीक है. अच्छा, सबसे सिंपल डेटा सेट कौन सा है? So two data, can you see data set and data set in the data set, the data points are in two different colors. Data points are in two different colors. Paint window दिख रहा है? Okay. Paint window दिख रहा है?
Yes, sir.
So let me say this is your class 1 and this is your class 0. Class 1 and class 0. So separating a class 1 and class 0 is very simple. You can just draw a line. It means this data is a very simple data. ये simple data है. Model बहुत आराम से build हो जाना चाहिए with less number of iterations, with less number of neurons, with less number of layers and all those things. ठीक है? Can you notice this data set is little more complicated. ये data set is little more complicated compared to the earlier data set. But over here also I can do a separation. मैं कुछ ऐसी line build कर सकता हूँ and it can separate both the classes. है ना? And if you notice, the complexity keeps on increasing. Probably this data set is most complex. Spiral है, ठीक है ना? So कोई linear separation ऐसा कुछ possible नहीं है. So number of iteration, number of neurons and all those things would be much more. ठीक है? See, let's take a simple data. Simple data हमने select कर लिया, ठीक है ना? Can you notice simple data को select कर लिया? Now come to this thing. Epochs. Epoch is nothing but iteration. Learning rate दिखता है? Learning rate. Then you have activation function. Activation function change कर दो ReLU. So there are other activation functions also, tanh, sigmoid, linear, which we will discuss. Regularization are nothing but your kind of your penalty L1, L2. ठीक है? Now let me reduce the number of neurons. So if you see this thing on the left hand side, can you notice there are only 3 layers? On the right hand side, can you notice the number of layers are many? ठीक है ना? Number of layers are many. तो मैंने क्या करा है? So this is your input layer. Now this is your, can you notice? Hidden layer. कितने hidden layer लिया है? 2. Let me reduce one more hidden layer. अब सिर्फ एक hidden layer लिया मैंने, ठीक है? सिर्फ एक hidden layer लिया. और epochs अभी कितने हैं? 0 है. I will press this button and model will start. Can you notice? So इसको ना एक बार ऐसे करते हैं. क्या हो गया? Suppose करो एक neuron. So कितने iterations आए? 23 iterations. And do you notice if you see the diagram on the right hand side, model has converged. एक line बीच में आती हुई दिखाई दे रही है, white line. Now this white line can easily separate your orange and your blue classes. So data was simple and within 23 iteration or less than 23 iteration, मैं जल्दी stop नहीं कर पाया actually, but your model has converged. अब थोड़ा सा complicated data set use करते हैं और जरा यहाँ पे करते हैं. Can I say model has converged? Still no. Model converge किया है क्या अभी? नहीं किया है converge. Number of epochs have gone to these many. Model को stop कर देते हैं. Let me increase the one layer. अब 2 hidden layer डाल दिए. मेरा model और complex हो गया है. It can handle even. Has model converged? Can we say? Answer is no. Model hasn't converged. Let's stop this thing and let's add the number of neurons. अभी भी converge नहीं हो रहा. एक और hidden layer बढ़ा देते हैं और कुछ neurons भी बढ़ा देते हैं. Can I say model has converged? ठीक है ना? देखो model converge हो गया. You can separate the blue circles and you can separate the Orange circles. So do you notice one thing? That when your data is complex, more iterations may be needed. You may need to increase more number of hidden layers. You may need to increase the number of neurons. So, acha, if you remember yesterday's session, then do you remember I had said one of the drawbacks of neural network is tuning of hyperparameter is a very tricky task. याद आ रहा है? और मैंने बोला भी था इसका नोट बना लो. So what can be the hyperparameters? Number of iterations, activation function, ठीक है? And how many neurons in each layer? How many layers? ठीक है? And then what type of cost function do you want to use? Then what should be your validation ratio? If you take the combination of these hyperparameters, so infinite number of hyperparameters. Okay? So tomorrow when I discuss this network, you will understand probably much better. But आज घर पे जाओ, थोड़ा खेलो कूदो और देखो किसका क्या impact होता है ना? And tomorrow, so do try playing on your playground and try remembering all the concepts which we have discussed. So tomorrow once we meet, I'll try to explain this network. I'll try to explain this network. What are the different types of another cost function? What is vanishing gradient descent and what is exploding gradient descent? Gradient vanish कैसे होता है और gradient explode कैसे होता है? All these things we will discuss. ठीक है? But as of now, I'll end the session. Thank you for joining.
Thank you, sir.
Thank you, sir.